Alright, let's study differentiation. If y is the function of x, that means y is changing with x. If x changes, y also changes. If the change is very, very small, if change is equal to zero and very, very small, change is nearly zero, very, very small, we call it as differentiation of y with respect to x. Now, we can call it in two different ways as instantaneous rate of change and exchange or differentiation to y with respect to x. There are nine standard formulas and five rules which you have to remember. First is rule number one. If y is equal to x to the power n, then differentiation of y with respect to x will be nx n minus 1. Remember, dy by dx is equal to y dot is equal to y dash. If I write y dot, remember it's dy by dx. It's the differentiation of y with respect to x. Let's take an example. Uh, y is equal to x to the power 7 by 3. So y dot, which is differentiation of y with respect to x, will be 7 by 3 x to the power 7 by 3 minus 1. Now let's solve this 7 by 3 minus 1 into 3 upon 3, which is 7 minus 3 upon 3, which is 4 by 3. So dy by dx is 7 by 3 into x to the power 4 by 3. Second example, if y is equal to 1 upon under root of x. So this is equal to 1 upon x to the power 1 by 2, which is equal to x to the power minus 1 upon 2. So dy by dx, which is equal to y dot, will be minus 1 upon 2 into x to the power minus 1 upon 2 minus 1. So minus 1 upon 2 minus 1 into 2 upon 2 1 upon 2 minus 2 upon 2 minus 3 upon 2. So dy by dx will be minus 1 upon 2 into x to the power minus 3 upon 2. Now the rule number 2. Rule number 2. If y is equal to sin x, then differentiation of y with respect to x will be cos x. Uh, Rule number 3. If y is equal to cos x, then y dot will be minus sin x. Rule number 4. If y is equal to tan x, then differentiation of y with respect to x will be sec square x. Rule number 4. Rule number 5. If y is equal to cot x, then y dot will be minus cosec square x. As you can see, the reciprocal of sine, which is cosec, both are in negative. Rule number 6. If y is equal to cosec x, then y dot will be minus cosec x cot x. Rule number 7. If y is equal to sec x, then dy by dx will be um, sec x tan x. With second last rule, rule number 8. If y is equal to ln x, then y dot or dy by dx will be 1 upon x. Last rule, rule number 9. If y is equal to e to the power x, then y dot will be uh, same e to the power x. And if last rule, this is the last rule, rule number 10. If y is equal to e to the power negative x, then dy by dx will be minus e minus x. Now, things to remember. If there is a constant while we are differentiating, if y is equal to c, then dy by dx will be 0. And the differentiation of y will be 0 if c is a constant. Second, if y is c into f of x, where c is any constant and f of x is the function of x, then dy by dx will be c remains as it is and y get f of x gets differentiated with dot represents differentiation. Third, if y is f of x plus or minus h of x plus or minus g of x, then dy by dx will be f of x, differentiation of f of x plus minus differentiation of h of x. We will differentiate each term separately. Now let's take an example. Y is equal to x cubed plus 2x squared plus 4. Now we have to find dy by dx. So dy by dx will be x cubed plus 2x squared plus 4 upon dx, which is equal to what's the differentiation of x cubed? X to 3x squared. 3x squared plus 4x plus 0. This is a constant, so it becomes 0. So dy by dx is 3x squared plus 4x. One more example. If y is equal to x squared plus ln x minus cos of x plus e to the power negative x plus 4x cubed minus tan x, find dy by dx. So dy by dx will be 2x and x and x to the power n minus 1. So here 2 is the n and x is x. So 2 comes here, 2x n minus 2, 2 minus 1, this becomes 1. No need to write plus 1 upon x minus cosec becomes minus sin x. So minus minus becomes plus plus sin x minus e to the power negative x becomes negative e to the power negative x plus 12x squared. Minus 10x becomes mm, sec x, right? Sec square x with minus sec square x. This is our answer. One more question. If y is equal to x to the power 4 plus 3x square plus ln x, find dy by dx. So dy by dx will be 4x cubed plus 6x plus 1 upon x. This is our answer. One more question. Y is equal to sin x plus e to the power minus x plus e to the power uh, minus x. We have to find y double dot. Now y double dot equals to d square y upon dx square. It's nothing but differentiation of dy by dx 2 times. The answer which we will get after differentiating y, we have to differentiate one more time. This becomes cos x minus e minus x minus e to the power minus x. One more time. This y dot, you have to find the pi double dot. So minus sin x plus e to the power minus x plus e to the power minus x. So rule number 4 or things to remember, the fourth part and things to remember. If y is the product of two functions, then dy by dx will be differentiation of the first function. The second function remains as it is, plus uh, first function now remains as it is, and second function gets differentiated. Yeah. So let's solve one question based on this. Y is equal to x squared sin x. Apply this rule. So y dot will be 2x dot sin x. This remains as it is. The first one gets differentiated. Plus, now the first one remains as it is, and the second one gets differentiated, which will be cos x. One more question: if y is equal to e to the power x dot ln x, find dy by dx of y dot. So dy by dx will be uh, e to the power x, where differentiation of only this thing is the same. Ln x plus e to the power x dot 1 upon x. Now, if you can see, we can take e common here, e to the power x. So e to the power x comes out common. So ln x plus 1 upon x. This is our answer. Now the last rule or the last thing in the things to remember is division. And why is the division of two functions x only two, strictly two? So differentiation of this will be hx dot differentiation of gx minus the differentiation of this thing which we didn't differentiate first, dot gx upon the differentiation upon the square of denominator. So, so I have a question for you. Why is equal to sin x upon x square? So what will be y dot? Y dot will be denominator comes first, x square dot. Now numerator gets differentiated, cos x minus. Now the numerator gets differentiated, but I decide the denominator first. No, now the denominator gets differentiated. So sin x dot 2 upon x square. This is our answer. Now let's solve some questions. First, y equal to x to the power minus 4 upon 3. Find dy by dx. Minus 4 upon 3 x to the power minus 4 upon 3 minus 1 into 3 upon 3. So minus 4 upon 3 minus 3 upon 3. So it means minus 7 upon 3. Second question, y is equal to under root of x. Find y dot, which will be uh, This is x to the power 1 upon 2. So 1 upon 2 comes here, x 1 upon 2 minus 1, 2 upon 2 minus 1 upon 2. Third question, y is equal to 1 upon under root of x. So y dot will be, let me simplify this. So residence 1 upon x minus residence x to the power minus 1 upon 2. So y dot will be minus 1 upon 2 x minus 1 upon 2 minus 1 into 2 upon 2 minus 3 upon 2. So question, x y is equal to x squared sin x sin y dot equal to 2x. This is the multiplication. So 2x sin x plus x squared cos x. Fifth question, y is equal to under root x dot ln x. Y dot will be 1 upon 3 x to the power minus 1 upon 3. And ln remains as it is plus under root x 1 upon x. Now the application of differentiation in physics. Of differentiation in physics. First, for linear motion or rugby motion, motion x, which is position, is the function of time. Like if we have this x-axis and there is a person here at t is equal to 0, he is here. At t is equal to 1, he will be here. At t is equal to 2, he will be here. So with time, his position is also changing. Uh, so for if you want to find its displacement, displacement is nothing but shortest distance. So it will be final position minus initial position, and their distance is total path. And the distance is total path. Now, thing to remember is the total displacement, the mod of it, because displacement can be negative, can be positive, can be zero, will always be less than equal to total distance. Now, average velocity, average velocity. It is nothing but total distance, total displacement for total time, which is equal to x final minus x initial upon t final minus t initial, which is delta x upon delta t. Now, instantaneous velocity. As you can see in its name, instantaneous. So the velocity at a particular instance. So this will be v is equal to dx because this is the rate of change and differentiation of x with respect to time. Because this is at a particular instance, so the change is very small or instantaneous velocity. I have one question for you. Question x is equal to 4t square plus x. Find its velocity. With respect to time. So this will be 8t plus 0. So 8t. One more question. This wasn't a question to be honest. A particle varies up with a particle varies according to the given function y is equal to 4t cubed minus 6t square plus 4t plus 8. Find its velocity at t is equal to 1. So we need to find its velocity. So velocity will be dy upon dt. So differentiation of this thing 4t cubed minus 6t square plus 4t plus 8 upon dt. This will be 12t square minus 6t plus 4. This will become 0. Now we are given at t is equal to 1. So substitute t is equal to 1. 12 into 1 square minus 6 into 1 plus 4. Hence 12 minus 6 is 8. So this becomes 10. 6t square. This will be 10. Average acceleration. This is nothing but total change in velocity around total time. T final minus A initial upon T final minus T initial. Delta V upon delta T. Now instantaneous acceleration. This is again acceleration dv upon dt. So if you observe, we have if velocity is equal to dx upon dt, if we differentiate position with respect to time, we get velocity, and if we differentiate uh, velocity with respect to time, we get acceleration. So if we differentiate uh, dx upon dt two times, we can get acceleration one time, differentiation two times. If you differentiate dx upon dt two times, you will get acceleration. But if you differentiate one time, you will get velocity. So let's have one question. Let us consider a particle's position as x is equal to 60 cubed minus 4t squared plus 3t plus 6. It varies with according to the given function. Find velocity and acceleration. Find velocity and acceleration at t is equal to 1 second. So velocity is equal to dx upon dt. This will be differentiation of 6t cubed minus 4t squared plus 3t plus 6 upon dt. This will be 18t squared minus 8t plus 3 at t is equal to 1. So 18, this becomes 1 minus 8 plus 3. So this becomes 13 meter per second. Now we also need to find acceleration. Acceleration is equal to uh, differentiation dv upon dt. So if you differentiate that twice, you will get acceleration, but we have of velocity that is 18 t squared minus 8t plus 3 upon dt, which means 36t minus 8. The 36 into 1 minus 8 plus 8, which is 20 meter per second. That's why our acceleration is 28 meter per second square. Uh, Wait, I'll cover a minute. Come back. One more question. A particle is moving along x-axis and its position varies with x as x is equal to t cubed upon 3 plus pt square upon 2 plus 60 plus 8. T is in seconds. T is in seconds. X in meters. So you have to find initial position. Wait a minute. So we need to find X initial position, which will be at t is equal to 0. So substitute t is equal to 0. We are asked position, not velocity or acceleration. So we will not differentiate x with respect to time because we are asked position. So x is equal to 0 cube upon 3 plus 0. This also becomes 0 to 1. 0 plus 0 plus 0 plus 8. This becomes 8. Therefore, initial position is equal to 8 meters. Second, we are asked average velocity. Average velocity. Average velocity is mm, total displacement upon total time. Mm, we don't have we average velocity is also x final minus x initial upon t final minus t initial. So we want four things: x final, x initial, t final, and t initial. In the question, it is said average velocity from 1 to 3. So this 1 becomes t equal to 1 becomes t initial, t equal to 1 is equal to t initial and t final is equal to 3 seconds. Now what's x final? X final is the position of x at t is equal to 3 seconds. So let's substitute 3 in this equation. So x is equal to 3 cube upon 3. So this becomes 27 upon 3, which becomes 9. 9, 9 plus 3, this is not 3 into 9, 27 upon 2, upon 2 plus 6 into 3, 18 plus 8 into 2 upon 2 into 2 upon 2 to 2 upon 2. If we solve this, we get 18 plus 27 plus 36 plus 8 plus 16 upon 2. The answer of this will be later second. So 18 plus 27 plus 36 plus 16. We get 97 by 2. 97 upon t. So x final is equal to 97 upon 2. Let me write the things that we have got. We have got x final, which is 97 by 2, t final, which is 3, t initial, which is 1, and initial rectifier. So x initial will be position of x at t is equal to 1. So x, x initial is equal to 1 square upon 3 plus 3 upon 2 plus 1 3. This into 1 square which will be 3 upon 2 plus 6 plus 1, 6 into 1 is 6 plus 8. So the answer of this will be, if we have to take LCM, 3 2 0 1 1. So we have to make the LCM as 6. So multiply this by 2, 2. Then multiply this by 3, multiply this by 3. This into 6 upon 6 into 6 upon 6 because we have to make the denominator as 6. So this becomes 2 upon 6. Yes. And 9 upon 6 plus 36 upon 6 plus 48 upon 6. So the answer of this will be 2 plus 9 plus 36 plus 48 upon 6. Right. 2 plus 9 plus 36 plus 48. This is 95 upon 6. Therefore, our x initial is 95 upon 6. We have got everything we need to calculate the average velocity. So average velocity will be uh, x final minus x initial 97 upon 2 minus 95 upon 6 divided by x t final minus t initial 3 minus 1, 3 minus 1. So multiply this by 3 upon 3, so this was 97 into 3, 97 over 3. 291 upon 6 minus 95 upon 6 divided by 2. So 291 minus 95. This becomes 196 divided by 6 into, if we change division to multiplication, it will become its reciprocal. So 1 upon 2. Now let's cancel 2 1 0 2 9 are 18, 2 8 are 16. So again by 2 2 3 1 2 4 9. Therefore the answer is 49 by 3 meter per second. Another thing they asked was initial position, which we calculated, average velocity again calculated. The third thing is instantaneous velocity. No, the velocity at any general time t. So, so any general time t is at an instance. So they are asking instantaneous rate of change, which is uh, d, dx upon d. T cube upon c plus 3t square upon 2 plus 6t plus 8 upon dt. So 3 comes here n x to the power n minus 1. N comes here, so 3 and 3 gets cancelled. So we have 2t raised to power 2 plus here comes 6, this becomes 6, so 1 3. It's 3t plus 6. So the answer is velocity will be t square plus 3t plus 6. And we are also asked that acceleration at any general time t. Acceleration is nothing but dv upon dt. Differentiation of velocity with respect to time. So this becomes the calculated velocity. So d of t square plus this is a function of v velocity. So this becomes 2t plus 3. That's why acceleration will be 2t plus 3. Question solved. Next question. Write the question. Displacement of a particle varies with time. Displacement and position are the same. We have to calculate velocity and acceleration. So the function of s is 6t cubed minus 4t square plus 8. So the velocity will be ds upon dt. Differentiation of position, which is displacement right now, upon the with respect to time. That will be differentiation of 6t cube minus 4t square plus 8 upon dt. This is of 18t square minus 8t plus 0 because this is a constant. 8. So this is our velocity. Velocity is meter per second. Do not forget the unit. 18t square minus 8t. 8t, okay? Now also we are asked the acceleration. So acceleration is dv upon dt, which is differentiation of 18t square minus 8t upon dt. This becomes 36t minus 8. Acceleration is meter per second. 36t minus 8 meter per second. Now, one important thing, we know that velocity is v. If velocity is the function of time, we get acceleration as dv upon dt and wait a second. And if the velocity is right, and if the velocity is function of displacement or position, we will get acceleration as v dv upon dt. V dv upon dt. So let's solve this. A is equal to dv upon dt. If we multiply this by velocity in denominator and numerator, we get dv into v upon dt here multiplied by dx upon dt because uh, velocity is dx upon dt, so dt gets cancelled. We have v dv upon dx. So if they don't give you velocity as a function of time, you can calculate it by a function of position by v d upon dx. And we uh, write this question for a one-D motion. Velocity of a particle varies with position, varies with motion. So we have to it does not vary with time. So we have to use the formula v dv upon dt. Dx v dv upon dx. V as let's use this yellow color. X plus 2x. X is in meters and v is in meter per, meter per second. Find acceleration of the particle at x is equal to 1 meter. So acceleration will be v dv upon dx. Thus we know this does not vary with time but does with position. So it becomes v. We know our v is this, and v dv upon dx we have to calculate. So first let's calculate dv upon dx, which will be 2x plus 2 plus 2x plus 2. This will become x square plus 2x multiplied by dv upon dx, which is 2x plus 2. At x is equal to 1 meter, so substitute x as 1. So 1 square plus 2 into 1 and 2 into 1 plus 2. This becomes 1 plus 2 into 2 plus 2. This becomes 3 into 4. This is 12 meter per second square. Therefore, our acceleration is 12 meter per second square. So, one more question. Question is x is equal to t cube upon 3 minus 3t square upon 2 plus 2t plus 4. X is in meter and t is in seconds. Find its initial position. So if we are given to find initial position, we will substitute t as 0. So initial position t is equal to 0. Substitute t is equal to 0. So 0 minus 0 plus 0 plus 4. This becomes 4. So our initial position is 4. Initial position will impact. So x initial to 4. If I have this path here, x-axis, because this is motion in 1D, only one dimension, not y-axis, not z-axis, only x. So at t is equal to 0, a particle was here, x is equal to 4, this is here. So its initial position is this. Okay. So we have to find now velocity and acceleration functions with respect to time. So velocity is dx upon dt. So our equation is t cube upon 3 minus 3t square upon 2 plus 2t plus 4 upon dt. So this becomes 3 comes here, so it gets cancelled out. T square minus 3t plus 2. This is constant, so this becomes 0. So our velocity is this meter per second. We also have to find acceleration, which is dv upon dt. This will be differentiation of the function which we found out of velocity, which is t square minus 3t plus 2 upon dt. This becomes 2t minus 3. So acceleration is 2t minus 3 meter per second square. So one more question, one more sub question. Find time when the particle is taking turn. So you have to find time when the particles take a turn. So this is for one dimension. Okay, so for it to take turn, the turn cannot be like this or or this or no. It should be this or this. For taking turn, its velocity becomes zero. For some instance, its velocity becomes zero. So in 1D, uh, wait a second. Bye guys.